So we're going to start the next chapter here. We're going to start chapter 3, which is going to be talking about functions. And before we get going too far into this, I want to scroll down here, and we're going to start with the vocabulary first. So it says write in your own terms, but I'll help you out here, and we'll start this. All right. So a relation is going to pair inputs and outputs. Okay. And once we have that pair of inputs and outputs, it's just it can be anything. Anything can be a relation. Any two variables can have a relationship. The next thing we're going to do is move on. We're going to move on to a function, which is a relation that pairs each input with exactly one output. Okay. Your domain is going to be all your possible input values. Your range is all the possible output values. And again, since you can pause this, I'm going to keep on roaring through the definitions here. So the independent variable is going to be the variable that represents inputs. And the dependent variable is going to be the variable that represents output values. Now up here when we talk about a relation, my domain is going to be all my x values. I missed this. And the range is going to be all my y values. All right, so that takes care of the vocabulary, and so now we'll rotate back to the notes part of this and see if what we can make out of this. So we're going to talk about a function. What is a function? Okay, again, we talked about that function where each part of my domain is each input has one output. Or each x has only one y. Okay, so we can do this by equation. I actually like to look at it like this. Okay, if I talk about people, okay, we'll talk about Joe, Bob, Sue, and hard to read, but L. Okay, there's my domain. And now we're going to talk about places. So we're going to go with the mall. We're going to go with the farm. We're going to go with Subway. And we're going to go with the library. Okay, now I'm going to do a bunch of erasing here, but Joe can go to the mall while Bob is at the farm, and Sue is at the Subway, and L is at the library. That's all possible. Joe, Bob could both be at the mall while Sue and Elle are at the library. That is possible. Okay? No issues there. What we struggle with, can Joe be at the mall and at the farm at the same time while Bob, Sue, and Elle all go to Subway? And this is where it's not a function. We'll highlight this. This is not a function because Joe cannot be in two places at the same time. Okay, that's what we have to be wary of. Okay, an x value trying to be in attached to two different y values at the same time. Okay, so we can do this by equation. The equation looks like this, something like y equals 2x plus 3. That's what the equation would look like. An input-output table looks something like that. Okay, using words we'll get to later. The graph looks something like that. A set of ordered pairs. So I didn't do that earlier, but ordered pairs would be something like 1, 2, 3, 4, 5, 6, that ordered pair. And we'll talk about what specifically about that ordered pair we have to look at. Okay? All right, so explain why the graph represents a function. So if we look at each x value, so we're going to highlight so I have 4, I have 3, I have 2, I have 1, I have 0. So because each of those x values was only assigned to one y value, it is a function. Okay, it says work with a partner, but we're not going to do that today. So again, what we look for is this. 0 is assigned to 8, 1 is assigned to 8, 2 is assigned to 8, 3 is assigned to 8, and 4 is assigned to 8. That is perfectly fine. That is like everyone being at the mall. Okay, so this is a function. Each x has one y. However, if we turn that around and try to say Bob is going to be at the mall, at the movies, at Subway, at the farm, at the library, all at the same time, this can't exist, so this is not a function. Eight cannot have more than one y. Okay. All right, so again, we're going to go, what we're looking for is we're looking for a duplicate x value, 3 here. 3 is trying to be multitask. He's trying to be two places at the same time, so therefore this is not a function. So when we look at this graph here, again, we looked at the other graph, I highlighted points. The x value of 0 is okay. The x value of 6 is okay. The x value of 4 is okay. 3 is okay. 4 is okay. But here's where we run into issues, and let's see, what can I do here? Oops, I want that one. I want that. I want to change the color of my highlighter to, let's say, I don't know. Let's say yellow, green. Let's go with green. There's my issue, and I'll go ahead and here is my issue, and I will grab a blue pen, and I will circle that, and I will circle that, because those two things, the x value of 5, is trying to go to 4, and it's trying to go to 5, which makes this not a function. Same thing with 7 out here. 7 is trying to go to 5, 7 is trying to be at the mall, and at the farm at the same time. It just can't happen. It's not a function. So when we see a list of ordered pairs, we saw that earlier. Here's what I'm looking for. I'm looking at my x values. I have -2, I have -1, I have 0, I have 1, and I have 2. Okay, all those blue dots are my domain. And this problem did not ask me to do this. However, it's going to appear in our homework. The range is going to be all my y values. So I'm actually going to change my color just so we can do that. My range is going to be 5, 8, 6, 6. I don't have to list it twice, and 7. Okay. Now what I'm looking for and trying to determine, is this a function or not? My domain never repeated. I went with -2, -1, 0, 1, and 2. So that means it's a function no matter what. I don't have to look at anything. Okay. However, if when I come over to here, I see a -1 and I see a -1, 0 and -1, 1, which means that x value is trying to be assigned to two different y values. So that means this one is not a function. All right, each radio frequency x in a listing has exactly one y. So that means we are on a function. The same television station x can be found on more than one channel y. So that means this is not a function. X equals 2. So let's draw that. Okay, we haven't had much experience with this yet, but x equals 2 is going to be a vertical line. All of these x values are 2. So like I said, this is x. This is 2, 0, 2, 1, 2, 2, 2, 3, 2, -1, 2, -2, etc. So all of these x values are trying to go to multiple y values, so this is not a function. However, if we put x values into here, let's say an x value of 2 is going to go 2, goes to 7, 3 goes to 9, 1 is going to go to 5. So therefore, with that mapping lays each x to only go to one y, so that means this is a function. Okay, now we have a test to determine if something is a function or not, or a graph is a function. It's that vertical line test. I kind of highlighted it previous page, okay? This one is a function because no matter where I draw my vertical line at, I'm only going to go through one x at a time. Okay, excuse me, 1 point at a time. However, when I come over here, let's say that vertical line represented x equals 4. It's trying to go to 2 and it's trying to go to 4 all at the same time. So therefore, this one is not a function. And actually, it's already written out there. I don't know why I'm trying to write it there. Okay? All right, so here's our extra practice. Here's what we're going to try to do and look at. It says determine if the relation is a function and explain. So again, we've got -2 going to 4, and we've got -2 going to 5, so this is not a function. -2 assigned to different y values. Okay, over here we've got a 0, a 1, a 2, and a 3. So since my x value never repeated, I can't be assigned at 2 places at the same time. This is a function. Each x only one y. All right, so determine whether the graph represents a function. So again, this is my vertical line test. So over here, we'll change colors and we'll go to red and to orange then. If I draw my vertical line right there, we failed the test, all right? This is a fail because it went through 3 and I went through 2, okay? So not a function. Over here, no matter where I draw a vertical line at, it's only ever going to go through one time, so this is a function. Doesn't go through multiple points. Find the domain and range. This was something different from, again, we really didn't hit this hard. I just went over briefly once. We have to remember my domain is all my x values. So my domain in this case is I have a point at 0, I have another one at 1, at 2, at 3, at 4, and at 5. So that's my domain. My range, this is all my x values, my range is all my y values. So I only had 2 here. I had a 3 and I had a 4. Over here, we'll write here so we can spread it out more. My domain again is all my x values. So if I look at my x-axis, I'm covered here to over here. So that means we're going to go from a -3. Actually, that needs to be, let's back up a second. Here to here. I didn't mean to, we'll take out here. I got an eraser. Let's use it. So -3 is my left boundary and +3 is my right boundary. So it's -3 to 3. Okay? Range. Again, the range is, I'm looking at my y-axis. There's nothing here, nothing here. My range starts at 0 and it goes to, it looks like 3. The function y equals 12x represents the number y pages of text that a printer can print in x minutes. So my independent variable, again, we didn't really strike that hard with my notes. I've kind of missed that in the notes, okay? The independent variable is going to be my x variable. The dependent variable is going to be my y variable. So it said that it can print a number of pages it can print in x minutes, okay? So the x variable is going to be the minutes. The dependent variable, or my y variable, is going to be the pages. And now it's asking me, what is my domain? So if I could make an XY table, it says my domain is 1, 2, 3, and 4. So I could take that and I could go with y equals 12 times 1. Was it 1? It was 1. So 12 times 1 is 12. And then do the same thing, I can put in a 2. 2 times 12 is 24. 3 times 12 is going to be 36. And 4 times 12 is 48. So I have made, what's my range then? My range is 12, 24, 36, and 48. Okay. All right, we're going to call that good.